Think about our roads, our bridges, all the buildings around us, the backbone of everything. They're always fighting wear and tear, aren't they? Potholes just pop up, coastal stuff starts crumbling from the salt, and what important military sites need constant, really expensive fixes. What if concretes, the stuff we use for almost everything, could be totally transformed, made way better at handling all these problems? Imagine it's stronger, but also lighter, lasting much longer, and maybe even surprisingly better for the environment. Welcome to the deep dive. Today, we're digging into something pretty incredible: graphene-enhanced concrete. The sources we've looked at suggest this isn't just like a small upgrade. It's shaping up to be a revolution, promising to make the world we build, well, stronger, smarter, really built for what's coming. So our mission today is to unpack how graphene actually does this. We'll focus a lot on the really critical uses, think military and defense, high-stakes stuff. But we'll also look at how it's starting to impact, construction everywhere. Okay, let's get into it. Graphene, this material that keeps amazing scientists, is being mixed into concrete. But what makes that mix so revolutionary? Why isn't it just another additive? How does such a tiny bit of this stuff make such a massive difference?
Well, that's the fascinating part. It's not just an additive. It really re-engineers the concrete from the inside, at a tiny scale. You know graphene, right?
Yeah.
That single layer of carbon atoms, super strong, incredibly thin. When you add even a really small amount to the concrete mix, it spreads out. It reinforces the cement binder itself, like on a nanoscale level.
Yeah.
Think of it creating this microscopic, super strong web inside the concrete. It basically stops those tiny cracks, the ones you can't even see, from starting or growing.
Ah, okay. So it's working from the molecule up, almost.
Exactly. That's why you get this superior resilience, performance that's just, well, way beyond standard concrete. It's engineered specifically to be stronger, yes, but also lighter, because you need less material for the same job.
Less material for the same strength?
Precisely. And much more durable. So structures last longer, much longer, with minimal maintenance needed. And here's a really key point. Needing less material means needing less cement.
Right, and cement production has a huge carbon footprint.
A huge one. So using less directly cuts down those carbon emissions quite significantly. It puts both performance and sustainability goals. Pretty neat.
That really is a game changer. Okay, so connecting that, it sounds like this stuff is almost tailor-made for situations where failure is just not an option. I'm thinking about the military, the defense sector. Strength, durability, total reliability, they're non-negotiable there. We're talking bases, airstrips, maybe tunnels, fortified buildings. How does graphene concrete meet those, well, incredibly tough requirements?
Yeah, that's a perfect transition. For defense, the benefits are profound. Let's take blast resistance. Imagine graphene's structure, that honeycomb lattice, acting like millions of tiny shock absorbers woven right into the concrete.
Wow, okay.
It dramatically enhances the concrete's ability to absorb and then disperse the energy from an explosion. Much better than just traditional steel rebar can manage on its own. So yeah, ideal for fortified buildings, anti-blast walls, ammo depots, places where, resisting explosions is absolutely critical. Then you've got corrosion resistance. This is huge, especially near the ocean.
Saltwater environments. Yeah, always a problem.
Always. Graphene helps create this really dense, almost impermeable barrier within the concrete. It makes it much, much harder for things like chlorides and sulfates, the stuff in salt water, to get in and cause damage. Perfect for naval bases, coastal defenses, military docks, sea barriers, anything exposed to that harsh marine environment.
Makes sense.
And there's more. We're seeing much faster curing times. Think about setting up a base or repairing a runway quickly.
Rapid deployment, right. Critical in some situations.
Absolutely. Rapid, durable deployment.
Yeah.
And because it lasts so much longer and needs fewer repairs, the long-term maintenance costs go way down.
Lower lifetime cost. That's always appealing.
Definitely. Plus, it has good thermal resistance, useful in extreme climates, Arctic or desert. And, as we said, the lower carbon footprint is a nice bonus, too.
It really sounds like it offers military engineers, contractors too, a real tactical advantage, not just building stuff, but enhancing capability. Can you give us specific examples? Like, where is this tech being used, or where could it really revolutionize things, mission-ready applications?
Sure. A major one is definitely airstrips, helipads, runways. The high-strength graphene concrete can handle the extreme loads from heavy planes landing and taking off, and also the thermal stress, from jet engines or just extreme weather. Keeps them operational longer, safer.
Okay, that's vital.
Sources also point to its use in fortified bunkers, hardened command centers, places designed to take a direct hit, basically. It helps absorb not just the blast itself, but also the ground shock that follows, protecting people and sensitive equipment inside.
Right, the shockwave traveling through the ground.
Exactly. And for the Navy, think about those docks and coastal platforms we mentioned. Truly corrosion-resistant concrete means they last much longer in that salty environment. It's also great for things like tunnel systems, maybe missile silos, underground shelters. You get waterproofing and pressure resistance that's hard to match with standard concrete.
Underground structures need that.
Definitely. And for troops deploying quickly, maybe setting up forward bases, that fast-setting property is invaluable. Build faster, get operational quicker, and you can even see the application for things like border walls, perimeter defenses, making them stronger, last longer.
Yeah.
It's a clear security benefit.
That's incredibly compelling, very specific stuff. But like you said, this started with material science. It's clearly not just for defense, right? This tech must be changing what's possible elsewhere, too, in ways that might affect our everyday lives more directly. Where else are we seeing these kinds of breakthroughs?
Oh, absolutely. That's a crucial point. The versatility here is pretty staggering. It spans across almost all modern construction. Let's look beyond the military angle. High-rise buildings, skyscrapers. Graphene concrete offers superior compressive strength.
Meaning it can take more weight.
A lot more weight. So architects can potentially design taller structures, maybe use less material overall, making the building lighter on its foundations. And importantly, it adds safety, especially in earthquake zones. More resilience.
Okay, taller and safer. Nice combo.
Then think about bridges, overpasses,
Right.
that added durability and crack resistance. It means they last much, much longer. Less maintenance, fewer closures for repairs. Which, saves money and hassle for everyone, especially under heavy traffic or in tough weather.
We could definitely use that on our roads.
Exactly. For roadways and highways, too. Helps them resist cracking, surface wear. Imagine major highways needing less patching, less resurfacing. Huge deal for busy routes. And back to the water marine structures in general. That's saltwater protection. Just as vital for commercial piers, jetties, seawalls as it is for naval bases. Protects investments against the ocean.
Makes sense. What about big infrastructure, like dams?
Good question. For dams, reservoirs, things that need to hold back water, graphene can help ensure leak-proof construction. Adds impermeability and strength. Also, critical energy infrastructure, nuclear plants, other power facilities. It offers really high fire resistance and structural integrity. Safety is paramount there.
Absolutely.
Even tunnel construction benefits, faster curing, high load resistance, long-term durability, all big wins. And it's filtering down into residential and commercial buildings, too. Eco-friendly options for foundations, walls, slabs, maybe more cost-effective in the long run.
So potentially even in our homes someday.
Potentially, yes. And industrial facilities floors, structures that need high load-bearing strength or resistance to chemicals, airport infrastructure, too, handling heavy planes, weather changes. It's really broad.
So, okay, wrapping your head around all this. What does it mean for you listening right now? It seems pretty clear that whether we're talking about vital defense systems or the buildings we live and work in, the roads we use every day, graphene concrete is a major leap forward. It's not just about building bigger or stronger. It feels like it's about building smarter, using materials that are more sustainable, that last longer, cost less to maintain over time, and can do things we couldn't really do before. This deep dive, I think, has really shown the profound impact graphene-enhanced concrete could have. We've seen how it can deliver unmatched strength, incredible durability, and even help with sustainability across so many areas, but especially, as we focused on, in military and defense. Now, here's something to maybe mull over after this. If advanced materials like this graphene concrete become widespread, how might that reshape more than just our buildings and roads? Could it actually influence our long-term economic plans, or even global efforts towards sustainability in a world that's, well, constantly changing? Something to think about.